No, he did not. Don't say that.
Maybe his phone did. Jesse, are you still alive?
He's getting data for me.
Ah.
Matthew learns. It's John. Hi. Just wondering. Remember how they did propose the heliocentric model, but the sun's going around the Milky Way as well, right? So is it not the acentric model now?
I'll just let you know, Matthew's. He went
Oh yeah.
outside to go view the eclipse, man.
We're black hole centric. Everything's moving around the black hole.
Yeah, the great attractor, if I'm not mistaken.
Can you believe? Are we all gonna get sucked in one day?
No.
Oh no, we're not.
Nope.
If I'm not
It's not how
mistaken, the
black-
Germans found it, the great attractor.
Yeah. Black holes aren't like vacuum cleaners.
What if we're already
really?
inside of a black hole?
What?
You're already in a black hole.
Yeah.
Ooh.
What
That-
do they
that's
think will
nuts.
happen?
He'll die
Spaghettification.
That's a given.
painfully.
I don't think it'd be painful at all.
No, you'd be ripped apart. That's not going to feel too great.
I don't like.
Getting
I don't even know if your nervous system would pick up on that sort of atomic scale.
maybe, but you're not going to live.
But doesn't time stretch as you go in anyway? So it just becomes infinity, so you live forever.
No, you die before you hit the middle. And then no one knows what happens at the middle.
You get spaghetti.
Yeah, a nice plate of spaghetti. You get a nice plate of spaghetti and you can watch the everything else get sucked in. You're like, dinner and a show. Oh yeah. We're about 2 minutes out.
That is a
from...
classic combo. Dinner and a show.
Mm-hmm.
And maybe well, never mind.
Flat tables are practical.
Wow.
I guess what I was going to say, I was just going to say dinner, a show, and a romantic evening. That's what I was going to say.
Oh yeah. Who
A
wouldn't
classic
want
combo.
Yeah,
to get romantic with a black hole?
Yeah, the trifecta.
Jesse, are you there?
I was trying to think of how to say it. The word romantic was the word I needed. Just very vague. Vague enough,
Gio
but
doesn't understand romance. We all knew.
Is that guy with the satellite? With the telescope gonna be streaming the moon today?
Yeah, I'm right here.
I actually never knew who are you?
Seafoam.
What's up, Sifo? Step it.
All right, let's.
You're in Central. Are you getting clouds?
Nope.
Nice.
Clear skies all night, baby.
Yeah, unfortunately, I'm getting clouds.
There we go. Heck yeah. Check that out.
That's nice, bro. I came just in time.
Yep, and it looks like totality has just started.
feel like that lighting makes it look more spherical.
And then in that's 58 minus 26. In 32 minutes, we will have maximum eclipse.
Hey, Seafoam, are you getting the enough to show stars and stuff for our parallax project, or
Yeah,
does that
I
help?
can see I can see every star in Leo right now.
Okay, good, because I'm out getting some pictures of the star and the dark moon.
All right. Let's time something at exactly the same time. Are you familiar with the constellation Leo?
No. And
All
frankly,
right.
there's enough clouds, I'm not sure if I could... Their stars are showing through. I'm using a 50 millimeter focal length lens on my DSLR, and so I'm getting the moon and stars.
Do you see a couple of bright stars? Maybe a little bit above the moon.
Well, how about how many moons away?
20.
I don't know. I'll look. I got it on a 30-second exposure out there. I'll go back out.
Yeah, because I can see Leo is really close to the moon.
I can see all kinds of different moons. There are all kinds of different stars around the moon.
Actually, directly next to the moon, there's a faint star, maybe about 6 or 7 away, toward the east. Very faint though. Can you see it?
I'm not sure. I'm inside now. I'm gonna go back outside. I'm gonna hook my night vision scope to my cell phone, because it can see the dark moon and the stars also.
Yeah. Let me get a lens for my camera.
It looks like someone's just sliding a Polaroid right across the moon, like blocking it.
A polarized Polaroid.
Like a polarized film, right? And it's
Yeah.
just like making it turn red. That ain't Earth shadows, boys. That ain't Earth shadow.
No, wait. That's the Earth. Just wave. You see yourself waving. Get up on your roof and wave.
How's that Earth shadow? Come on.
It matches our predictions of the globe model.
What's the prediction?
Well, it's convenient when it comes from what already exists in the sky.
I guess so.
Works out pretty well.
Yeah, when it's predicted in advance, yeah.
What is? That the moon should still be lit up
The
when
time,
there's no light.
the time, the place, how much of it.
The time and place is very curious. I'll give you that. But just the optical phenomenon of what we're observing right here, and the sort of heliocentric model, this idea is that the atmosphere of the Earth is causing this sort of. I mean, there should be a really fine cut line in my interpretation. That's what I would expect to see. That would be my prediction. It's not what you see there.
I don't know how. Like, I would understand if it was like near the horizon a bit, but it's like directly up above where I'm at.
Yeah, it's a full moon. It has to be a full moon for the geometry to be correct. If it happens at, like, where you think it would happen near the horizon or something. Well, wait a minute. You could be near the horizon.
What's causing the reddish color?
You could be near the horizon if you were in somewhere like England right now. You'd probably see it close to the horizon.
Yeah, but what's causing the reddish color in your paradigm?
Our atmosphere.
Yeah, the sun, the light bending around, getting the atmosphere. Basically, Earthshine.
Well, it's not Earthshine. It's different because Earthshine is a reflection.
Okay, I guess. Okay, good point.
But basically, when the sun is low in the sky,
Why isn't there any red right now? If you notice, after it goes away, then it turns red. Then the light comes back.
There is. Where you
Because the white light washes it out. The direct white light washes out the red.
What were you gonna say, Seafoam? What was your explanation?
Yeah, so when the sun is low in the sky, so like a glancing blow, like during sunrise and sunset, because of the angle of the sun in the sky, the atmosphere that it goes to filters out all the higher wavelength light and only leaves the red light to go through the atmosphere unscattered. So
it
with the globe
polarizes
model,
it, but what's
not
polarizing?
polarizes it. No, not polarized. It scatters the light and filters out the blue and leaves
Right.
the red to go through unobstructed. So it's not polarized. It's just getting filtered. Only the red light is coming through. And so
But how is
because
it getting filtered? Is my like I don't understand.
the same way that a sunset is red. For the exact same reason a sunset is red,
No,
the moon is red.
I
Because it's
understand that, but what I'm saying is if it's directly at my zenith, how is refraction basically causing that? I don't get it.
because if the moon is at your zenith right now, that means the sun is at your nadir.
Mm.
So the sun is exactly opposite the moon in the sky right now. Or very close to exactly opposite.
Yeah, but the occultation is coming. It's like from the bottom up. The sun is set to the west, which would be it would be coming from the east side then of the moon.
Well,
Why is
it's
it
not
flipped?
the
It's flipped.
it's
then.
not it's not because the moon, it's not the earth moving that causes the shadow, it's the moon moving. And the moon moves backwards relative to the stars. So because the stars go east to west, the moon slightly drifts west to east. So because it drifts west to east, that's why the shadow starts on the western half of the moon and travels across, because it's moving backwards relative to the stars around it.
Well, it's moving
Backwards.
slower. Yeah, the stars are moving faster. The moon's moving slower. So it's not really
Exactly.
going
That's
west
not-
to east. It's just going a slower pace than the stars.
But that doesn't really, like, that doesn't explain how the Earth's shadow is causing that.
It's because the sun is directly opposite. So the light from the sun hits the earth and the earth blocks that light from the moon.
Right. So, wouldn't it be on the other side of the moon? Wouldn't it be in the other corner, the right-hand corner? Because from where I'm at, the moon is like directly at my zenith, and then to the south, right? So it should have no occultation on the bottom right corner, but it's on the bottom left corner. That's what I was saying. It's like the opposite. So I'm trying to figure out how that doesn't make sense to me.
It's because, like I said, if you were focused on the stars, if you could lock your head in place with a star, you would watch the moon travel backwards. You can observe this in many ways. You can observe how the moon travels. It still travels east to west with the sky, but it does that at a slower rate. So relative to the background stars, it travels in a backwards, right? So the Earth's shadow is always in one place relative to the background stars. It's not moving. And it's the moon that is traveling backwards across it. So since the moon drifts from the west to the east, that's why it's going the opposite direction.
Huh.
It's kind of hard to explain with words, and I don't.
No,
I'm not the best.
I'm just trying
Best
to
linguist.
wrap my mind around that and the fact that it's like a reddish color. So like it's filtering for some reason at this time.
Yeah. Well, other times the moon isn't in the Earth's shadow. So the Earth's shadow is always there. It's just every once in a while that the moon is going to travel through that. And let me see. Jesse, are you outside at all?
I just stepped back in. My computer's inside, and I'm going to give you a sample picture. And if you think that's sufficient coverage of the sky, then I'll do it at an exact time for you.
Boom. Let's make it happen.
Okay, did you get my DM?
DM Dungeon Master. Whoa! Holy cow!
So that's a
That's a
10
nice.
second. That's a 10-second exposure with a f1.8 lens and ISO 800 or something. Does
All right,
that
I'm
cover
gonna
enough sky?
That.
Or am I overexposing the moon a little bit too much?
No, I think you can see the disk of the moon really well there. That looks good to me. After I take this next picture, I'm gonna stop my stream for now.
No.
So just for
Do you
the
think
minute.
that he's got to save battery and stuff? I think it's rather curious, right? That I mean, if the size and the gravitational sort of all that's all perfect, right? And plus the moon is going the wrong direction, the opposite direction to everything else in the solar system. That's a curiosity.
No, it's going in the
What,
same
what,
direction.
what do you
But-
mean it's going in the
but-
opposite direction?
Yeah, everything in the solar system orbits counterclockwise.
You want to blow your
Having trouble
mind and
getting my
say,
head around the balls.
you want to blow your mind? The moon orbits the sun, not the Earth.
Well, what's interesting for me is always that apparently there's a central point between the Earth and the Moon. It's 1,000 kilometers below the crust of the Earth, and that's actually the central. So the Earth doesn't.
It's like 1,000 miles away from the center, I believe. It's deep in the Earth.
No, it's 1,000 kilometers from. I know it wasn't even that. I think it was like 1,000 meters. I'll have to go look that up anyway. I kind of wanted to point out, just like if anyone knows the explanation for this, but if the scale is proportional to the size, which but they're moving at different speeds, wouldn't the size, the scale, and the orbital speed, like you'd think that the moon and the sun, the moon and the Earth have to be in some sort of, I don't know. Do you get where I'm coming from? I don't know. I'm having trouble explaining it. Like if the size and the scale and the proportion are required for the gravitational thing to all work, and then this is why we get the perfect eclipses, then why aren't the speeds the same as well?
Because they're orbiting?
Because if it was too far out, like if the moon wasn't in its perfect spot, right? If it was too far out, it'd start creeping away, and it wouldn't have been caught in that perfect suspension of going round and round for millions and millions of years. So it's in a perfect harmonious balance.
That's for the solar eclipse, not the lunar eclipse.
Sure, but I'm just wondering why the bodies are all moving at different speeds.
I'll be right back.
Why would they move at the same speed when they're different distances from the sun?
Speeds is like different arc minutes. Rotational speed, I should probably point out, not actual kind of, what's the other term? I don't know. Like I've probably gone off into a little bit of a weed. I'm trying to just thought about this for the first time. So why would they be different? But anyway, if anyone else wants to jump in with something more relevant.
I'm just trying to figure out how is there a blood moon reddish glow when it's like at the zenith, and you're saying the sun's at my nadir.
Yep, and the sun is basically opposite you. Yeah.
So
That's
how could that?
The center of the moon's going red, though. It's not even just around the edges.
Yep.
Right.
Yeah, it should be rainbow moon.
It's being refracted. It's being refracted around by the ring of atmosphere and the.
So why no rainbow?
It almost seems more red in the center than on the outside, though.
Wait, Seafoam, are you coming back with your footage?
Yeah, I was just testing with my camera. Yeah, Jesse, I can get with my camera the same exact stars you're getting.
Jesse's not here right now. He just said I'll be right
Please
back.
leave
I
a
think he's gonna
message
get more.
after the beep. Beep.
All right. Well, when he comes back, I'll let him know that I can see the exact same stars he's getting in his pictures. So we'll be able to do a test here.
He's busy getting data, which I thank him for
Did you?
because we just got temperature data for both during the eclipse. But the thing is, I'm not gonna be able to look at it until tomorrow. I should be sleeping right now. But yeah,
Did
Jesse
you?
said he would also do a temperature thing for me.
Did you clean your lens, Seafoam?
I'm using a different optics than when I do my telescope streams. So this setup has a lot less dust than my
Okay.
Barlow lens and teleconverters and stuff like that.
It's all
Speaking of
good.
which,
You inspired me to clean my screens yesterday or whatever that was.
I'm
I was
glad I
like,
can
what
be
is
a
that?
positive force in this community.
No,
See,
yeah, I love your little your setup, bro.
not all Globers are bad.
I mean, that's still cool to bring to the table, regardless, Glober, flat earther, like everyone can observe the same celestials, bodies.
Exactly. I believe in a synergy between us. There shouldn't be I don't think there should be much of a divide. We can disagree on trivial things like shape of the earth. But yeah, I get some other lenses for my camera so I can do this thing with Jesse.
How long do you think you'll take before the live stream's up? Because it's about to be super red right now. You said 32 minutes, right? It's been like half that.
Oh yeah, and what's this? Gonna be like 9-10 minutes? Will
Yeah.
be max eclipse.
Yeah, I want you
Yeah,
to
I'm
get
just
that
trying
for
to
sure. Yeah, no,
conserve battery, but yeah. I also took it off because I was testing something else as well.
You better hurry up. It's about to be over.
It's not about to be over. It's
3:20.
nowhere close to.
Got another
What's
half
this
hour.
hustle culture?
40 minutes. Got another 40 minutes of 100% eclipse.
All right, let's share my camera again.
nice.
There we go. So unfortunately for you guys, this is as bright as I can get it.
I was just about to say you can't make the shutter speed higher or whatever.
Nope, this is as bright as I can get with a live view.
Okay.
Because it's at max ISO, but it's also at 30 frames a second. So the max shutter I can get is 1/30th of a second.
Are you able to center it?
Yeah, I can. I'm just trying to keep it in the same spot. Oh wait, actually I gotta take a
There you
photo
go.
right now. Hold on 1 second. I'm doing
I'm
10-second exposures now. Alright, Jesse, I was saying that I just
How
took a
red it is
picture
in the
with my
bottom.
lens
Uh-huh.
and I could see all the same stars you can.
Is that good?
Whoa! Yeah. So
Hey, look at
yeah,
this one, guys. Someone in the other channel's from Chile. Look, it's upside down.
ooh. So yeah, if you can go outside now, Jesse, this
Yeah.
would be the perfect time to
So
do it.
let's pick a time.
Yeah. So I'm doing this in between pictures. So the next picture I'm taking is at 1:50.
Okay, so I should take one at 50 past the hour.
Let's do like 1:52.
1:52? Okay.
Yep.
It'll be
So 1:50.
11:52 for me.
Oh yeah, time zones and stuff. But yeah, if we shoot for 11:52, I should have all the same stars. Let me test my new setup here because I put a teleconverter on it.
Well, if you do 58 past the hour, that will be the moment of maximum eclipse.
Me and Jesse are just trying to get background stars at the same time so we can measure lunar parallax.
We're trying to do
Very
stellar
cool.
doxing of each other.
Yeah.
I'll dox myself. I'm in LA County.
Ooh, okay.
I just came in
not...
from outside watching it outside. It's pretty cool.
Okay, so that idea is not gonna work, I guess. Too dark with that.
So I'm doing 10-second exposures with a f1.8 lens.
Oh yeah, let me change my F number too, because I'm at F10 now.
And what I found was when I go to ISO 100, the moon hardly overexposes any of itself at all. And I'm also shooting in RAWs, so that's the RAWs. I can go back and change the ISO later.
Oh yeah, I should change it to that too for this.
So this allows us to get a non-overexposed moon to get a pretty good picture of its perimeter, and then gain up the ISO everywhere else and pick out even the faintest stars.
Yeah. Closest F number I can do is 3.5, but that's all right.
I could put my 3.5 lens on. What's your focal length are you shooting at?
No freaking clue.
It
I
doesn't
can
matter.
check.
It doesn't matter.
Yeah, but as long as our moon isn't overexposed, we'll be perfectly Gucci.
The bright edge might be at 100%, but it's not like really blooming bad.
All right.
Okay, so you said 52, huh?
Mm-hmm.
All right,
So
I'm gonna head out there.
Just about to take my next picture. Once it hits 50.
Are we supposed to be able to see right now? Because it's got that.
No. Sorry, I'm
Okay.
doing two things at once here. Once me and Jesse are done, I can put back up the stream. We're doing science.
Yep. A lot of people do science.
No, it's just an observation. It's not a scientific experiment. Not to get all
True.
QE on it, but
Well, you didn't know this proves the ground right here? It's an object in the sky, therefore we're on a big ball. And that's what we're seeing in the sky. Talk about what they say, the ground in the sky. They're literally saying the thing you see in the sky is a direct representation of being on a massive ball. So they're completely making that link, especially with this one with the lunar eclipse.
What I see in the sky, there's a bunch of there's a moon and a sun, same size, that move overhead, and stars circle us. That's what I observe.
it is a pretty big coinkydink that they're the same angular size, or just about.
That's what makes solar eclipses so special.
I mean, how many just say with that part of it though? People who believe in a creator and have a globe Earth idea, would they
We lost Geo?
Yeah, he does this. He leaves us in a suspense all the time.
Oh, what happened? Did my mic go out?
You said,
Yeah.
will they?
We missed all the profundity. Start again.
All right, from the
man.
top, Geo.
All right. Let's see. So Jesse, it's about to be 52 in about 5 seconds. So you want to do a countdown?
Oh, it's already 52 for me. It's 53
Oh,
actually.
really?
Yeah.
They gotta calculate your pings.
All right. Let's do a countdown then. How's that?
Yeah. So if you guys can hear me, what I was saying is that if you believe in a globe Earth and a creator, would you just say that the creator made the sun and the moon the exact same size purposefully? That that's the creation? If you have the globe Earth idea, that the fact that the sun and the moon appear the same angular size and then eclipses, like, because I have friends, that are and colleagues and whatnot that do think the Earth's a globe, but that's what they would say. They think the whole thing is created by a creator and all that. So they would just say the sun, the moon. So would that be the explanation? Is that they purposely are like all the distances were perfectly created to be set up so that they look the same angular size to make eclipses and all that? That would be the way the creator made it. I'm just trying to like steel man it, I guess, with
You
that.
should read The Privileged Planet. It's amazing. It talks about all the miraculous things about how the Earth is in the perfect location, and it's just it goes on and on. It's really cool. They just updated their book for their 20-year anniversary.
Hey, Seafoam?
Yeah.
It's called The
I'm
Privileged Planet.
I'm sorry,
Nice. It's
I
a
didn't
book.
get it. I didn't get it till 52 and 20 seconds.
Hey, that was about the same for me. Are you still out there?
No, but I sure can go back out there again. It's all set up.
Yeah. Yeah. When you do
Oh, I
that,
see.
let's do a countdown.
Well, I can't hear you when I'm out there, but I can.
Oh.
But tell me what time you have, or I can. Do you have a seconds clock in front of you?
I do.
Okay, I've got the seconds is 57, 58, 59, 60 for 54 after. 2, 3, 4. Are we synchronized?
Oh, we're exactly.
Okay, so just pick a new time, like say 55, and I'll be on the button this time. I just was distracted.
Yep.
You
Yeah,
got a
Taylor,
lot
I
of
just looked up that book. I see what you're talking about. Yeah, it says it was with the Discovery Institute, but yeah, I see this book you're talking about. The Privileged Planet: How Our Place in the Cosmos is Designed for Discovery. So yeah, I see what you're talking about. And they're talking about the Copernican principle and all this
Even
stuff.
the atmosphere is perfect where it would block out these harmful things, but we can actually see the stars. Like the fact that we can see the stars is even a miracle in itself in the globe model. It's really amazing. It's like it goes through all these amazing things that just make it fit perfect.
Jesse, let's shoot for 56 and 15 seconds. How's that? 56 and 15 seconds? Oh, did you hear me or no,
Me? No, I was
Jesse?
call you.
Let's shoot for 56 and 15 seconds.
56, 15?
Yep.
All right. Starting, and then the ending, of course, will be 10 seconds after that, right?
Yeah, so it'll end at 25.
Okay, 56, 15.
Yep. And then try to do another one at 57:15. Just so we can be absolute certain we're good.
The fact that we have weather is amazing. Evaporation, things like that. To pull, and we have surface water, which is really rare. If any other planet does have water, it's either frozen or under the surface or whatever. It's it's frozen. But we actually have water on the surface, which makes it really amazing. And land. You have to have that interface too. Yeah. I mean,
fresh
yeah.
spring water. Wow, what an
Mhm.
amazing creator!
Or it was all just by accident.
All right, I'm back. This time I
Right,
hit the
you
button. I hit the button right at 56:15 this time. It's exposing right now. Well, it's done now, but
Okay, I feel silly. I chose a time that was too early. Let's do 58:15.
Come on,
I'm
guys, get
sorry.
this together.
okay, so 58:15.
I'll be like
Yeah.
Jeremy.
Is anybody else freezing their ass off watching this?
Yep.
Nope.
It's cold here.
When that live stream coming back on Seafoam, I might go check it out outside real quick.
Oh, my PC just died.
All right.
So,
So soon.
unfortunately, the opposite of soon.
Wow.
Okay, I gotta get.
All right, I'll run back to base, spread a mist. I'll go outside. Go check it out.
Isn't it weird how whenever we do see these quote unquote exoplanets, just assuming that they're being like genuine with them, even though from Earth we just see like a couple pixels and we've only ever captured them a few times, but assuming that they're being correct with their exoplanet, the Earth looks nothing like any of them. Think about it. Like they're all uninhabitable. Like we have days and nights. Our Earth is not tidally locked. It's in the perfect zone. It's basically has water and land interface, allowing for mineralization, like basically minerals to seep off of the rock and go into the water, which would be needed for life, like even to support us right now.
I'm back.
I mean, it just goes on and on. And I remember a point they made about like we're the perfect size to like actually build fires, which is like kind of a unique point. I'm like it's just really weird. Like we're right in between the size of an atom and the universe, even if the whole model was correct, right? And like we'd be at the perfect size to like do things like build fires and everything like that. And then our atmosphere, it protects us, but it's not too thick to where we can still see the stars. And it's really amazing. I mean, the points are really cool. And then the moon and the sun just happen to be the same size. It just goes on and on.
Can you see it from your
Alright.
house? You should look at it. It looks pretty wild.
Yeah. Also, Jesse,
Yeah.
I got mine at the same time as you.
I got mine right at 58:15.
Great. And even if we were like 5-10 seconds off, that wouldn't change anything.
Oh, I don't think we are though. I think we're right spot on.
Yeah.
I have my finger on the trigger and it clicked the instant that rolled over to 15.
That's great. Yeah, so just whenever you can share the raw picture with me.
All right, it's a cannon rod. Can you deal with those?
Yes.
Oh, can you convert that to a 16-bit something or another and get it back to me?
I didn't take my I forgot to change mine to raw, so I took it in JPEG, which
Oh,
is but
I took it in both simultaneously.
oh yeah, send me the JPEG. That should be perfectly fine.
Oh, okay. Well, in the raw, you'll be able to pull out the dimmer stars a lot better.
It's fine. There's enough really bright stars that it won't matter.
Okay, good. I had to choose between having a bunch of really bright stars or having the moon not blooming.
Yeah, for me, the moon wasn't blooming at all.
All
Hey,
right.
Taylor, what you were saying was a really good point. Like you were saying, the other exoplanets that don't like look anything like Earth. That was a really good point because like you have to be the right size to make fires. Like you were saying that, and also like trees, all have to be like the right size for the wood to be usable to make fires. Like there's a lot of things on this landscape that are incredibly unique that make it like so in depth. Like the idea that we're just one ball of all these other balls. Why would this one have so much nuance and all the sizes be right and everything? Those are interesting points.
Well, it's just a random cosmic coincidence built out of chaos. Whoa.
I think one of the main things that was peculiar to me was the sun and moon being exactly the same size, and then the stars like never changing. I know they say they're so far away, but that's still weird to me.
But they're not exactly the same size. It actually does change. Sometimes we get that
Mhm.
special type of eclipse with the sun and the moon,
Annular.
where we can see more of the solar corona. Sometimes we can't. So they change the angular size actually.
Mhm.
I feel like I'd
The
see
moon,
different stars like throughout the year, like every year, or year
you
by
do.
year by year, different
What's
Well,
different?
stars.
like throughout the year, you see different parts of the sky, but like there aren't different constellations last year than this year.
Right.
But
But if
yeah,
you look at
as
the
the year goes
animation
on,
of the Earth
sorry.
flying through space, like it just seems like it changed a little bit.
It does throughout the years. I've done the demonstration a million times here, where I showed a picture from 1901 and then a picture from 2022, and some of the stars did actually change their position.
Like one doesn't it change like 1 degree according to the almanac?
Less than 1 degree, but like their physical location in the Orion Nebula changed.
It was actually you can find that animation that shows that whole constellation where the stars are moving around inside the constellation over a period of many years that they've been able to track it.
Hmm.
Yeah,
But like
galaxies
that,
can too. Like
They move.
galaxies that we see
They don't
overlook
move.
it.
Nah, compared to
They
us,
do move. They actually move way too fast.
they do.
Yeah, they do.
Like
yeah,
Andromeda.
This is when you bring up negative stellar parallax.
Dark matter. They had to invoke.
Dark matter.
well, dark matter
What about when the
hasn't
stars
proven
go the
theory.
wrong way from the prediction? Then what happens?
When does that happen? Has that ever happened? What do you mean wrong way?
Yep.
You never heard of it?
When has a star gone the wrong way?
You took like a sample of like 10 stars, and like 60% of their predictions were wrong about which direction they were going to go.
Like, what do you mean direction they're gonna go?
So a
Like
certain
over a period
parallax,
of like,
reverse parallax, basically. So they took 10 stars, and they were trying to figure out the sizes of the stars based on the parallax, but they went the wrong direction. 60% of them. I'll have to find the paper. It was
Yeah,
pretty
I know. I
wild.
gotta dig that up so I can reread it. It's a interesting read.
And something else interesting happened. What was it, last week, Peter? When I was outside and I was looking at Venus, and I was like, wow, look, Venus, it's like 10 o'clock at night. And then Venus was like in front of the moon.
Venus
And
doesn't go in front of the moon.
I saw it myself. What are you talking about? I asked like 5 people on Discord, walk outside, take a look at it, and that's what was happening.
How does
No.
Venus
Like
how do you see
in
Venus in front of the moon?
in
You
front
saw
of the
Venus
face of the moon.
in front of the moon? Oh, please.
Yes.
Because
What were you
did you
smoking?
get pictures of it?
No, no,
I,
no,
I,
no
I
picture.
couldn't even find my camera until tonight.
I'll show
Oh
you.
darn!
Yeah.
Well, I mean, because if
Yeah,
you got pictures of
convenient.
that, it would be
Why
definitely
don't
be
you
worth a
explain?
Nobel Prize or something.
Maybe
Hey,
someone
Listen,
posted a picture.
How about
Maybe
just an
someone.
stop,
Someone
observation?
will-
you tell me.
Oh my goodness.
Wait.
Hey,
Hey,
you
guys,
guys,
hold on
I
a second.
posted it.
Thank you.
Chill
Picture,
out.
the
Thank
picture
you,
of Venus in
Basico.
front of the. Gosh, the picture of
Yeah.
Venus in front of
Chill
the
out.
moon.
Don't freak out now. Yeah, there's Venus in
No,
front of the
I
moon.
wanted. I didn't need a
That's
picture. I
from the
wanted.
same.
You
That's
saw it.
from the same Reddit post. That's from the same Reddit post
Where is it?
where the
Where?
OP admitted. I'll have to find it, but the OP admitted in that same exact Reddit post that he was wrong about that being Venus.
Well, what is
Controlled
it?
op.
No, I want to hear what he has to say about what did I trust you. What did you see? What did you how did you identify Venus? How big was it? What did you see when it went in front of the moon? Please describe your experience.
Who are
It was
you asking?
dark and winter night. It was
Whoever said
cold.
they saw you, whatever you saw with Venus getting in front of the moon, what did you see? What did it look like to you?
Well, I'll tell you this. I didn't see it go in front of the moon. I saw it next to the moon. And I was just wondering, like, how is it possible that I'm even seeing Venus? So I walked out onto my porch and I was looking around and those are the only two things that could have been those. There was something, some sort of celestial object up in the sky that was very, very next to the moon. And apparently, according to what Theastocles is saying at the moment, he has pictures of it. And a lot of other people do as well.
Well, I've seen Venus next to the moon, and usually when it's high in the sky and the sun's set for a while, it's usually a half moon, like the half Venus.
Nice, you
Like,
bum.
it's a half Venus. If you just take a real simple 12x telescope, like an old, in the old days, I have an antique telescope I use. You can totally see that it looks like a miniature moon, very, very tiny, next to the big moon,
Right. Well, they call it the morning star, right?
the evening
And
star.
the evening star, depending on what time of year it is.
Right.
Okay. Well, then how could you possibly, according to the heliocentric type of model, how could it possibly be seen at night?
Oh, 12 at night. You
What?
probably
Geometry.
Because
that might have been
it
Jupiter.
can only be seen in the evening and in the morning. You can't see it at midnight.
Yeah, you probably saw Jupiter or Saturn, probably Jupiter,
I
because Jupiter
can-
is very bright too.
Yeah, there was recently a really close pass with Venus and the moon. That's when that Reddit post was taken. At around the same time, there was a close pass, but there was not an occultation of Venus. There was not a recent occultation of Venus, and you would need an occultation for there to be even the slightest chance.
So, do you know what the OP said it was?
I don't know what he said it was.
Is it still a star?
It was probably a plane or a helicopter or something like that, possibly traveling toward him. So it didn't look like it was moving.
It's a
But
little.
it was.
It's a little donut light with a dark spot in the middle. It's probably a reflection in a window or something.
It's way too big to be Venus too, because at the time Venus is still a very thin crescent. It's not going to be a big. That's way too big to be Venus too. Because if you can see the moon, if the moon is that angular size in the picture, Venus is also going to be enough to where you can see the crescent. So I can tell you for absolute certain that's not Venus in front of the moon.
Do we know when
And
this particular photo was taken?
I guess the Redditor, Matthew said the Redditor deleted his account, so
Oh, that's convenient.
it would be hard to say. But
So why?
is-
Just because of this kerfuffle. And then the other thing is like stellarium. If we had that, sorry, I get a lot of noise. If we had that time stamp, why can't we just rip out stellarium and find out if Venus was anywhere near it?
because we know that nowhere on Earth was there an occultation of Venus.
No,
at that
you didn't hear what
time.
I said, did you? I said,
No,
like,
I'm
if we know
saying-
the date and time, we can find out where Venus was in relation to the moon.
Yeah, and we will find that it will have been outside the disk. That's what I meant. So an occultation is when the moon passes in front of something, and occultations only happen in specific certain areas.
Right,
And
but if
so because there was no occultation of Venus anywhere on Earth, it couldn't have even been inside the disk of the moon to anybody, let alone in front of it.
yeah, but it was a low pass of Venus in front of the moon. That's what happened, though. It's a little different.
Hold on. Oh, sorry. I was gonna say, hold on. I want Seafoam to look at this and tell me what this is, if it's possible to replicate.
Yeah, let's see it.
I timestamped it too.
It got a cool intro. I like the letters crossing the screen.
Right? Check this shit out, though. This shit's crazy.
All right. That is really weird.
Dude, when I saw that was like one of the first things I saw looking into all this stuff. I saved it because of how crazy it looks. It looks like a fetus.
Kind of does.
It's so weird. So I wanted your take on it because you use telescopes and stuff. But
Yeah,
You think
so
that's something to do with the frame rate? Oh, sorry to chime in.
obviously Venus wasn't in the sky doing that. It wasn't
well,
in the sky. It wasn't in the sky spinning. So, what it could be, just purely speculation. Some cameras have like an auto stabilization thing, and it could be where the camera just kind of crapped out on the auto stabilization.
dude, if you look at it, it'll change its vector. Like it'll start spinning like towards you rather than just on the side. Like it looks like it has like a spin. It's
Yeah,
pretty wild.
something weird was
The
happening with
digital, the
the
digital
camera.
zoom can do that kind of very strange. All those pictures, people start talking about lights in the sky, and I got my P900 and my P1000, and I took a picture of the star, and it has all these different colors and this weird shapes, and every star you look at looks a little different. That's all that's a digital zoom.
Dude, you can pause that and frame by frame
Yeah,
and see. That's not like I was saying. Like how could like some of that stuff frame by frame? I don't. It
Did you hear
doesn't
what I
look
said
like.
about the digital zoom?
Yeah, but
it's
it
The
it's
doesn't
digital
look
zoom,
like
the
That's
it.
the
digital
definitely
most
zoom makes
ridiculous
things
thing I've
look
ever
like
heard.
really strange.
It's
Hold
not
on, hold
digital
on, guys.
zoom.
Hold on a sec. The digital zoom, once you go into digital zoom, it makes everything look very strange. It's taking a very, very faint light source and just amplifying it. And now you're seeing the basic components of the algorithms that actually allow it to be
What?
seen. So
that's not what
You're
digital
going
zoom
off on
is.
a stretch
Yeah,
on
that's
that one.
not
Digit,
digital.
It's
di-
not
Let's hear.
even
Wait, let's let
close.
yeah,
Seafoam. Let's let
digital
Seafoam talk. Go ahead.
digital zoom is literally just cropping the image. That's it. Digital zoom is just cropping the image and then scaling it to
Oh,
show the screen.
that makes so much sense
So,
actually when you say it
so
that way.
yeah. So what I think is happening is something was happening with the camera. Maybe it was windy and they're on a nasty little itty bitty tripod,
Nah,
and
dude,
the
it's
wind was
calm.
blowing it around.
You can hear the
S-
crickets beforehand. It's calm.
yeah, maybe something happened with the auto uh stabilization, but uh because it's such a long trail, I can tell that their shutter speed was really high. So I think if they did close down their shutter speed
Dude, okay.
considerably,
Bro, if you
they
if
would
you go
see.
yeah, if you go to 6 minutes and 6 seconds, it like flips.
Yeah, it's
It
it's
like
really strange. I'm not doubting that it's really
dude, dude,
strange.
dude, when you see it flip at 6 minutes and like 10 seconds or whatever, it like looks vertical towards you. Like that strange.
Okay, the other thing in regards to when people are going to be doing astrophotography, and I'm not going to claim that I'm an expert with it, but if I'm just out in a clear sky, no clouds, nothing like that, obviously, and why would I point my camera at a certain part of the sky? It's because I can see it with my naked eye. I'm like, oh, that looks really, really weird. I'm going to get out my camera. And then I will use an optical zoom, not a digital zoom. I don't ever use digital zoom. I also have a telescope. Well, I had a telescope. I donated it to my nephew. And all of a sudden, you zoom in on it with optical zoom.
What are you
No
talking about? What
focusing
are you zooming
required.
in on?
Say again?
What are you talking about? What are you zooming in on?
A light in the sky, one of the stars, what we call stars. I also have pictures of
Are you just saying in
Saturn.
general, or are you saying in relation to that video I
Well,
just posted?
no, it's similar to that. I'm just saying that some people say, "Oh, Andrew, you don't know how to focus your camera." It's like, yes, I do, but
I
I
don't
didn't
think
even
anyone's
have to.
saying that.
Okay. Well, no, because people have accused me of that when I have shown these different. I have my entire, actually not the entire thing, but I have some of these dancing stars that I recorded myself. I didn't believe people when they showed it to me, and yeah, they're dancing stars in the sky, and they're not like the other ones. And I've zoomed in on the other ones as well, and it looks like a bright ball of orange, nothing fancy. But other ones are not like that.
Yeah,
Well,
so
I challenge you to
it,
recreate that seafoam.
I don't have a broken camera.
Is that what you're saying? It's broken.
Wow,
That's
that's
why
a
it's
bit
doing
of
that.
a draw, man.
Yeah, I definitely think there's something happened with the camera. Something wrong happened with the camera. I'm thinking most likely something with the auto stabilization broke when they zoomed in that far, and
Mm-hmm.
it was a positive feedback loop of just craziness. Because 100%, I don't believe Venus was in the sky making a shape like that. It would have been reported by people. Because this video is like 20 minutes long, 13 minutes long. Someone would have seen this. Someone else would have seen this. So I think something wrong happened with their camera. And because their shutter speed was so high, it created a trail, like almost like a star trail. I think if they had shut their shutter speed down considerably, each frame would just have an in focus Venus just moving uh, throughout the sky each frame.
Dude, that's so weird that it looks exactly like a fetus, though, bro.
Yeah,
And
this is a very
it
very
happened on a
strange
certain
video.
day. So like in the video, I really don't like their channel at all. But they're claiming that it's like the Feast of Trumpets, like it was filmed on a certain day, according to the Kabbalah. Let me see.
Now we're cooking. I didn't know that.
Yeah.
All right, let me put a couple of these digital artifacts, and yes, it does. Yeah, the digital zoom is a cropping type of function, but then it expands whatever small little noisy object it has. It scales it up, but the objects look crazy. Now let me just put one in there, and you can. I know you already know this, but let me just put this in so you can refresh your memory about what the digital zooms can do. They look like these kind of things. Are you looking in?
Okay.
Are you looking in chat? Hello.
This has
Yeah,
nothing to do with
that
digital.
has nothing to do with digital.
Yeah, but
So
these things also are.
the first one is definitely an out of focus star. That's just not focused. And
No.
they need to. Yes, it is because there's a donut shape. I could get that same exact donut shape with my own telescope.
Yeah, I trust what what you're talking about when it comes to that
I
stuff.
actually did that. I actually did that last night.
I showed.
Eden,
Yeah,
are
I
you?
watched that.
Yeah. So the donut shape comes from when you defocus your telescope. That's the shadow of the secondary mirror.
Mm-hmm.
And you can also see the dot in the middle, which is the diffracted light around the secondary mirror, creates a bright dot in the middle of the shadow. The second one is definitely in focus, as close to in focus as you can
And if you
get.
look at it, it'll be moving. It'll be rotating or having all these different. It'll be morphing in other types of shapes as you're looking at it. So and I think you're also right about this weird baby-looking, fetus-looking thing. could have been just an error or some type of malfunction of the camera to create that. Like you said,
Yeah.
depending
That's
what
some
was actually
error.
Venus, yeah.
That is some error, yo. That's
Well, yeah,
crazy.
Yeah.
when the cameras make problems, they usually are pretty noticeable. They have
Could I
issues.
could I
So
address
what? So these things don't look spherical at all. What's up with that?
The Venus pictures?
No, any of these stars. Stars don't
Yeah.
look spherical, but they're supposed to be in the globe model.
Well, you got to remember, these are point sources. You can't resolve the disk of a star
Well,
unless
how
you
does
have.
NASA do it?
It's just light. It's just trying to. It's a small dot of light, and you're just magnifying a bunch of noise, basically, in the
So you're
distance.
saying it's actually just there's a sphere out there with some other sun reflecting light on it, and that little bit of
No.
light reflecting off that sphere is
No, that
beaming billions of miles an hour, and then or billions of miles, and then showing up as like a fractal cymatic pulsating light
no,
frequency.
it is the
No,
source
so
of light.
it's
It's the
like
source of light, and it is just basically a noisy light image that you're trying to zoom in on. It's a garbage image, and you're zooming in on something that's just garbage. It's just blasting light at you. Very
So
I
tiny.
was
yeah, think
talking more about
you
like
can think
I
of
was talking more about like an exoplanet would be that in
yeah,
terms
so
of
you
a
can think of a point source as like if your friend was all the way down all the way down a street as far as you could go and turn on his phone flashlight. No telescope. I don't think any telescope would be able to resolve the disk of this guy's phone's
So
flashlight if he's all the way down the street. So that flashlight is going to be a point source.
so
And so
okay,
what's happening
let me
yeah,
ask
what's
That's
you.
not
happening
material.
If that's the case, if no telescope could ever zoom in on a point source light and get the disk of it, then why does NASA make CGI cartoons of it to push an agenda?
like
Why
where do
can't
you
they
see that?
why can't they just every star that you've ever seen that's represented in a CGI or composite image? What do you mean?
We
It's not
see
they
we
don't
Like what are
show
you
you
trying
the
to
clusters
actual
of stars.
stars. They don't
We
show
see
what they
clusters.
actually look like.
We see clusters of stars. We know what our star looks like. We basically give them shape when we want to do some kind of animation to it, but we can't ever
Right.
see
like
a sun like we can with a filter to see just the uh, the
So how
surface
come
of
they
the
don't do a side by side? Why don't they
of
be
what?
like, oh, this is an artist rendition of what the star actually looks like versus what we can actually see empirically with our telescopes? You just said that
yeah,
we can't
cuz
actually see the point source ever with any telescope.
yeah, so what we can see with our telescope is a dot. That's it. All we can see is a dot.
But that
Just a
pulsating
little
dot is supposed to be a sun
yeah, a very far away sun. And then the thing is the
with all these different
pulsating.
colors and pulsations. You think those are just
Yeah.
suns?
Just
Well,
imagine it,
the
and it worked
pulsating
Because
fine.
is the pulsating is due to our atmosphere. And so the amount of rainbowness and pulsation is directly correlated with the altitude angle of a star. So just like last night when I pointed it at Sirius at like 15 degrees, it was very rainbowy, very oscillating.
Yep.
But then when I went up near Zenith to the star Castor, which was the blue double
The
star,
double star. Yeah.
you could
It,
see that there was a lot less movement, no rainbow effect actually.
but it looked like a fractal image, bro. I mean, there was still scintillation, but like
Yeah, you still get that, of course, but
that's pretty
mo
wild though. Like, all right. Think about it this way, right? In the paradigm, it's supposed to be trillions and trillions of miles away.
mhm.
But how much more reasonable is it to say that it's actually a point source light that's way closer than that that's actually being refracted through like some type of layer, like a firmament? Several layers. It even looks like several layers.
Why would you say it's refracted?
Well, I mean, how else would you describe it if you're having a light source and it's going through two different lenses? It's going to refract.
That refracts only when it goes through differential medium and there's an angle of incidence. So if you're looking
Yeah,
straight up to the
yeah.
star, there's no
I'm
you're going
I'm
through
saying
many
that
layers, but you're not having an angle to it. So there's no diffraction. There's no
I'm
refraction.
claiming like in speculation, I'm claiming that what if there is actually some type of lens that it's going through, and not only just one but two, and you can empirically see that with that double star caster at that angle. It looked crazy.
I'm also gonna warn everybody that the total eclipse ends in just 5 minutes.
Is anyone live streaming it right now?
My computer died. I'm really sorry, but I did live stream it for a little bit while it was at max eclipse.
Yeah, because I'm totally overcast. I can't see the moon at all.
Yeah.
You
And
say
then-
it's max eclipse for the next 5 minutes, but it won't. It'll still last until like 3 for me.
Okay.
Yeah, so max eclipse was at like an hour ago, and now it's exiting totality, and then in about 3 hours it'll be completely over.
And the way the sun looks in our sky, it just seems like if you got further away from it, it would just get smaller and smaller, and it would just be like a very like dim little yellow dot. By the time you got too far to see it, it would never turn into what these stars look like.
Well, these are dim little dots.
These are pulsating frequencies that are like making all kinds of like sacred geometrical pulsations, and we can just set that aside for the moment. But I mean, they don't look like a sun at all.
Well,
They
yeah,
don't
again,
even look like what a
they're-
sun would look like far away. They don't even look like what a huge sun would look like far away. If there was a sun that was like, 1,000 times the size of ours or whatever, or what they claim the sun is in the heliocentric.
because
They
their
just don't
point
fit any of that.
sources, their point source is traveling through a moving, refracting atmosphere. The amount of twinkle a star has in astronomy is a quantity known as seeing, and seeing is directly affected by the stillness of the atmosphere. When you have jet streams going through, you will see your seeing statistic is awful, because up in the sky there's going to be tons of moving air, changing density, refracting, twinkling, all that stuff. But on a night where the sky above you is still, that's when you get perfect seeing. And then again, like I said, it's directly correlated also with the altitude angle, how much atmosphere you're actually looking through.
Yeah, that's fine. That would be the same on a planar surface as well. You'd be looking through a lot more. That's not really in contention. The
Yeah,
other
but
parts
like
might be though. The other
It's just
parts.
about how
the
far away they
twinkling.
are, bro. Like, just you have to actually accept that in your paradigm, like it's that far away. Why? Like, why is that so key? Is it because they actually really haven't moved
Well,
spots, even though we're moving at like crazy speeds? So
Well,
it's
dude,
like,
well, I was gonna say that
they
too. Like,
can-
how they say the sunlight's like 8 minutes old or whatever. It's like 8 minutes. Well, these starlights they're like thousands of years old. So this little point dot you're seeing is actually, they claim, traveling years and years to get to you, to then pop up as a little pulsating thing in your sky after, like he was saying, all the refraction and space dust and everything else.
that's crazy. Like, what about the inverse square law? Like, I don't. How
Well,
do
the
we see
then
inverse
there's
that?
that.
the inverse square law is based on ratios of distances, not
Exactly.
actual. So
No, exactly.
if
Yeah.
if we were half as close to these stars, they would be 4 times brighter. But the inverse square law doesn't tell us that, oh, you're this many miles away, you can't see me anymore. The inverse square law tells us how the amount of light will change with our distance, but on a relative scale, how relatively, if we were this distance x away, and then we travel 2x away, then it would be a fourth as bright. But the inverse square law doesn't tell us that at 500 miles, then we can't see it anymore. It's too dim.
Well, the thing is it's I understand, like, if it was closer and in your mind, that it would have to be 4 times brighter, but it could also be 4 times smaller than your conception. You know what I mean? Like, what the size is all based off of the angular diameter of that said light. And that's all based off of the astronomical unit, which was just assumed, which is basically the distance to the sun. Like, it's okay, it's 93 million miles away to the sun. That's 1 AU. All right, well, according to the angular size of Venus and Earth and all these other assumptions about these ratios, it's like then we're like filling in the gaps of like how far and how bright these stars are, and it's just the math is insane. It's just absolutely insane. It's all just based off of a false premise in my mind. But you understand where we're coming from when I say that? Like, how do we know we're not looking at a disco ball in the sky that's being projected from like the center of Earth or something like that? I
Parallax
know it sounds,
measurements. Parallax measurements.
but see, those parallax measurements are all based off of the original assumptions. So they can literally go out the window. You can just you can literally plug in whatever numbers you guys want.
Well, we do things like measure the angles to the moon when it's half lit. And we get that ratio of 400 to 1 just using simple trigonometry as Aristarchus did.
Why would it have to be half lit?
Because that means the sun is directly opposed to it at exactly a 90-degree angle. If you have just as much unlit as you do lit, which you can count the pixels to make sure that is that, then you have a 90 there.
Counting
Then
pixels.
well, if you have a digital camera and you take a picture of it, then you see
So
that
anybody-
the shadow on the moon is half the diameter, which means that there's a 90-degree angle between the light source and the moon, and then you. And then at your feet, you measure an angle from your feet to the sun. And if that angle between your feet and the sun and the line going to the moon is 89 degrees, roughly, then you know it's somewhere between 300 and 400 times farther away. And then you can.
I would love to talk about that more, but the only person I know of right now that's live on YouTube is a buddy of mine, Carl FE Nation, which is F space E space Nation, and he's live streaming it right now.
Nice.
He's been live streaming it for like the last 2.5 hours. So
Okay.
just letting you guys know.
Yeah, it's you gotta admit it's crazy assumptions, Zanick. Like, they're just lights in the sky, bro. How the hell do we know what distance and size?
Well, I just got done
Dude,
telling you.
the one that you were saying yesterday with that Seafoam did with the like the fractal, the double star, dude, that thing was so unique looking. Like it had these like little wings to it, like triangles and stuff. Like it had like triangles and like wings and like this multi-level, and it was like this fractal thing. That's not a ball of gas burning billions of light years away.
Dude,
Mhm.
it looked absolutely nuts. Like if I went on Stellarium and looked up the star Castor, I would not see that. Guarantee you. I guarantee you wouldn't look like two blue crosses that are just
Yeah, that's what it looked like. They were like crosses, and they had like blue and yellow. It almost looked like an insect. Like it had sort of like inset, like there was yellow, like gold kind of inside the blue parts, and then it would be like there was like these blue triangles and then the yellows that was like fitting in on each side. Like it looked like a geometric structure of some sort. It didn't look anything like what they say stars are.
It looked pretty
Like I
wild.
remember my telescope isn't collimated either. So my optics are a little bit out of alignment.
Come on, you said it wasn't collimated yesterday and you were gonna do it. Come on, Seafoam.
Then I got extremely cold. My hands were freezing last night. I was gonna collimate, but I'm like, not at this temperature. And then I'm gonna be
What is
filming
collimate?
this.
I'm sorry.
It just basically means making sure both my mirrors are perfectly in line with each other.
Okay.
And if they aren't, then I can't get perfectly sharp photos.
How much did your setup cost overall? Ballpark.
Probably somewhere around 3,000.
Oof. That's what's
Roughly.
up, though.
That's a really good setup.
Basically, so it's when you go back to that calculation I gave you, that tells you how many times farther away it is than the other object. Just the simple trigonometry there, and then you can do simple measurements on the ground of the Earth, whether it be flat or round, to see how far the moon is away by using.
No, I
similar
understand. It's
techniques.
just ratios. It's very simple to calculate.
Yeah.
I'm just saying the numbers.
Well,
the numbers you guys incorporate in there.
Well,
is
when you get
nuts.
no, it's not. But that's not. So using these simple measurements, you can then get numbers. Eventually, it's something that's closer. Like the moon is closer. It's it's still 250,000 miles away. I mean, it's 200 50,000 miles away, 20,000 miles away. But you can measure that by two spots on the Earth. You can get enough deviation in those angles to say how far away is this object from me if the two angled measurements are different. Even off a flat or a round Earth, you could figure this out. Then you know for sure the sun. If you're getting 250,000 miles away to the moon, you know the sun's got to be 400 times that.
No, dude, that's such a big. What are you talking about, bro? That was such a big logic leap.
It
You
wasn't.
gotta know
Okay.
the sun is the
watched
same angular size. It's the
No,
same
it has
angular
nothing to
size
do
as
with,
the moon.
it has nothing to do with
Have-
angular size. It has to do with the first measurement, which I told you was the half lit minute. And if you agree with the moon being half lit like that, that the sun would have to be at a 90-degree angle with respect to us, that it can only light up half of it. That means that line down the middle of the moon is a 90-degree angle at that point between us and the sun. And if you measure our feet to the sun, because we're seeing both in the sky at the same time, which is unusual, only happens a few times a year, you can then get that 89-degree angle. That 89-degree angle will give you the ratio of 400 times. So 400
Okay,
times
400 times what?
400 times whatever distance you can calculate to the moon. Now we know it's not 3 or
So
4,000 miles
assumed.
away.
So that's an assumed distance.
No, you can measure that distance to the moon.
How?
Measure it with angles also.
How?
You in LA and me in Northern California, we both take measurements to we're on the phone right now live. What's the angle from level to the moon? And we can get some values, and you'll get different numbers, and the different numbers will allow us to give a rough estimate of how far away it is. We might be
Yeah, I
20,
mean,
30,000 miles.
you're definitely, you have to admit that there's going to be some assumptions in those calculations, though, right?
Like
Like,
what?
where are you putting the assumptions? Because I know you're
I'm
going to
not
put them
making,
somewhere.
I'm not making any assumptions. We have a light in the sky. We know it's there, and we're going to see what the difference is when I move on the ground some distance. What the angular change is by my movement on a linear or even a curved path.
Okay, well then, there's no way, based off of that, if you're talking about the distances on the ground here on Earth, then you're looking at what, 3,000 feet, 4,000 feet high?
Oh God, no,
I mean, miles high. Sorry.
no. How could that be?
If you're just using plain trig to like using the ground, if I'm in one position and then you're in another position, and you go by the distance to the angle, right? If you're just doing trig that way, then it's going to be way closer than 256,000 miles or whatever.
No, because that ratio that proves the ground has to be curved, so that wouldn't work on how far that would be. Not 3,000
No, we're
miles,
not
it'd be
even talking about
250,000.
flat or globe. We're literally just talking about what you just said, the ratios on how
Right.
far away the moon is. Okay. If I'm
It's
using two distances, known distances here on Earth, right?
mhm.
Then that ratio, that angle relationship between the two distances here on Earth and to the moon can't be bigger than a certain amount, right? Like 3,000, 4,000 miles based off of what you just said.
If the Earth was flat. But the problem with that is
I
you
don't even
can't.
I don't even see how it would be. It doesn't matter if it was a globe or not either. The distances
Of
would
course
be
it
too
does.
short to
We
add
know.
up to
We know. We know.
256,000.
We know that if you travel from one point like Northern California or to Southern California, 40 degrees latitude to 30 degrees latitude or something, you have a 10-degree change. We know it's a 600-mile difference,
Okay.
and then you'll
How do you
get
jump up to
those
256,000 miles after that? I want to know.
because you along the way you see the change in that angle be linear. If it changes in the angle is linear, then you make that measurement. Then the angle to the moon suddenly becomes not 3,000 miles, becomes 200,000 miles. If you do it on a
I,
flat surface, it becomes 3,000 miles high, something like that, close to that. But we know that the sun, the moon is not 3,000 miles. We can actually send light to the moon and have it bounce back.